a good one of Key Performance Ideas, and I'd like to welcome you to our webinar, Oracle Data Integrator, a Success Story, presented by Jason Jones. Jason Jones, an Oracle Essbase certified developer, has extensive experience in developing, tuning, and enhancing Essbase, Hyperion Planning, and Oracle Data Integrator solutions. His experience is complemented with deep programming expertise that includes developing software in Java, mobile solutions for the iOS platform, relational databases like SQL Server and Oracle, and knowledge with many scripting and related tools that add value to EPM solutions. He is passionate about performance tuning, optimization, and the intersection of business intelligence and mobile solutions. Thank you for joining us today, Jason. We're looking forward to your insights on Oracle Data Integrator, a Success Story.
Well, thank you, Nissa, for that wonderful introduction. Just to expand upon my passion for performance tuning, that's not just the systems themselves, but also looking at how we can tune the development process and gain efficiencies there. That's one of the things I'm hoping to convey today, as well as the great benefits that ODI has brought to a client of ours. Here's the agenda for the webinar. We're going to talk a little bit about our client, what Oracle Data Integrator is, the problems and pain points that our client was having without ODI, how ODI solves those problems and brings additional opportunities. Then we'll walk through high-level ODI functionality and benefits. We'll talk about the lessons we've learned, how to get started with ODI, and then have a question and answer session. So a little about our case study client. They're a large health services company. They have a significant Oracle database footprint with many schemas and many servers. They're currently in the process of rolling out Essbase, which will give them even more places the data needs to be loaded, and they're transitioning to new database servers. So the physical server use in many of their data movement processes is about to change. We'll see how ODI can help with this. Lastly, their data movement processes have grown organically over the years. So there's no really unified strategy for moving around data. It's just get it done somehow through a combination of SQL scripts, batch files, custom programming, and other things. This approach can work, but starts to break down and become unwieldy as more jobs are added and complexity grows. ODI really brings a lot to the table to keep the situation under control. What is the Oracle Data Integrator? Well, ODI was originally developed by a company called Synopsys. Oracle saw what it could do and how it was architected and thought it would fit very well into their portfolio. So they bought Synopsys in 2006. ODI is commonly referred to as an ELT tool rather than the more common industry term ETL. So this means it's an extract load transform tool instead of extract transform and load. We'll talk about the significance of this in just a moment. In a nutshell, ODI is a tool for moving data from one place to another and transforming it according to business rules and needs. Data is typically moved between relational databases such as Oracle, Microsoft SQL Server, and others, to and from Essbase cubes, including planning, text files, web services, and more. ODI is Oracle's strategic product for data integration. They are and have been putting significant resources behind its development. This is the tool to use moving forward. It's also the evolutionary successor of tools such as Oracle Warehouse Builder. So let's talk for a moment about this notion of ETL versus ELT. Let's say we have customer order data in one database system. We want to load some or all of that data to a different server that analyzes those orders. How do we accomplish that? In a traditional ETL architecture, we have this third server, the ETL server, acting as the middleman. It extracts the data we want from the source system, transforms it somehow, and then loads that data to the target system. This works well enough, but can have some downsides. The ETL server in the middle needs to be a robust and often expensive server since it's working with a lot of data, not just for this one job, but also for dozens, hundreds, or even thousands of jobs. Now let's take a look at the ELT architecture. We're going to say that the source and target are already robust and very capable relational database servers that we manage. In fact, the source and the target might even be on the same server already. What if we could leverage this existing capacity by having the database servers do the heavy lifting for us? This is what ODI does. It conducts the ELT process through our existing infrastructure, effectively obviating the need for a middleman server processing all of the data. Of course, if we need ODI to process the data as a middleman, we can easily configure that as well. ODI is very flexible when it comes to configuring data movement processes. Here's some of the problems and pain points experienced by the client. SQL procedures are being used as a de facto ETL solution. This can work, but we've simply outgrown it here and we need something better. These procedures are time-consuming to develop and they're hard to maintain. We have poor visibility into the errors that may occur during processes. They're difficult to integrate with other data sources. We're duplicating code between development and production servers, causing maintenance headaches. We're having to write extra code when we want to try and log the steps in our processes to see what's going on. Documentation and comments are often lacking, and they're difficult to troubleshoot. ODI gives us a ton of solutions and opportunities to improve our situation. Our ETL jobs are going to be easier to develop and maintain. I think the maintenance aspect is huge here. If you've ever had to go fix something in some custom code that's been around for a while, maybe you wrote it, maybe someone else wrote it, you know it can take a long time just to understand what is going on, let alone try to fix it. The consistent and logical way that ODI processes are set up means that it's much easier to jump into a job, figure out what's going on, make changes if necessary, and be confident in those changes. We can seamlessly work with different relational databases, with Essbase, with planning, with text files, web services, and more. We can set up email alerts in case of errors. We can easily switch jobs between development and production systems without duplicating any code. We have built-in process logging, the ability to pinpoint any errors that may occur in our jobs, and more. So let's take a quick look at the flow of data between systems for our client. We have two major Oracle servers and an Essbase server. ODI is installed on a separate server that, for our purposes, isn't in the data flow, but rather orchestrates the data flow. Here we have data flowing from an OLTP system to an operational data store. Data from both systems is flowing to an Essbase server. Each system has many schemas. In the case of the Essbase server, we have multiple cubes. Additionally, ODI is also going to help us with our data when our data flow involves additional servers we might not be using yet from a data flow perspective, but want to. This can also include text files, web services, and other technologies that ODI supports. So now on to ODI functionality. Knowledge modules are the flagship feature and concept in ODI. They're strategies for working with data in various technologies. In ODI, we express from a business rule perspective what data needs to be moved and transformed, and the knowledge modules take care of the how. They're best practices templates that generate code from our concepts. We have reversing knowledge modules, which are RKMs. These import the existing structure of a data server so that ODI knows about what it's working with. For example, if we have customer information in an Oracle database, we use the Oracle RKM to extract that model of the data to ODI so that it knows about, for example, the customer name, address, phone number, and so on. This model of the data is what we will design ODI jobs to work with. We have loading knowledge modules, LKMs. It is used for extracting the data itself out of a system. So in the above customers example, this would be the process that pulls the actual customer data out of the table. In the case of loading data from a text file, the LKM would read the text file as if it were a relational database table. We have integration knowledge modules, IKMs. These update and add data to a data store such as a table. These are very powerful, give us the ability to not just load data to a table, but to be very smart about how to actually load the data. We have journalizing knowledge modules, JKMs. These are special knowledge modules that can be easily configured to watch a particular data source, like a table, keep track of what data has been updated or added. This gives us a very powerful ability to design a process that will work with only the updated data, such as new customer records, as opposed to processing the whole table. We also have checking knowledge modules, CKMs. These are a powerful way of validating data that's being processed to ensure it meets our business rules. For example, we might want to validate that all customer records being moved from one place to another have a zip code. If they don't have that set, we can set that data aside and deal with it later. So models are ODI's comprehension of a data store, such as a table in a relational database, the format and contents of a text file, or the dimensions and data in an S-base cube. We create ODI models for the sources and targets of data transformation jobs. And as just mentioned, we can use the RKM, for example, to build models automatically based on our existing data stores. This allows us to get up and running with our existing data stores very quickly. Let's say our source model is a table of customer first names, last names, addresses, and phone numbers from a sales system. The target model might be in a separate system, like a customer mailing system, which has the customer name, which is a combination of their first and last name, and address. So the transformation in this case might be to take updated records in the sales system, combine the first and last name, then add and update these records in the mailing system. We can enhance models to add constraints and requirements to them. For example, we can say that a requirement of that customer mailing system model is that the customer name and address must not be blank. This prevents invalid data from entering the mailing system database from our process. One of the big wins for our health services client has been our ability to define in one place requirements of tables with respect to business rules, and then reuse these models for many additional interfaces. So interfaces are the real workhorses of ODI. They move data between the models, as we just talked about. We just looked at an example where we transferred data from one table to another. We can actually use multiple tables for our data source. For instance, what if customer orders are in one system, customer names and addresses are in another, and we want to build a mailing list just for customers that have placed an order in the last 30 days? We tell ODI to link together the tables in these two possibly disparate systems based on the customer ID, and choose which fields we needed, such as name, address, and so on. And start to think of interfaces as an easy-to-create and modify analog for all of the code we have been writing, a process that now occurs in a graphical and intuitive editor. We can also easily add very complex behavior with the click of a button. For example, I could turn on the Use Journalized Data feature with one click. Now only new and updated records will be processed. This is a feature that previously took a considerable amount of code and effort to set up. In addition to the mappings of the interface that we just talked about, we also have a lot of control over the flow of the interface. We can quickly turn on if data being moved should conform to the constraints of the model we defined earlier. We want to automatically reattempt to load data from a previous job that didn't transfer because of not meeting constraints. Choose the loading and integrating strategies. For example, in the case of updating data in an Oracle database table, there are actually several different integration knowledge modules we can choose from depending on our needs. At our health services client, the biggest one here is data recycling. We automatically reprocess data that didn't meet requirements the first time around and attempt to reprocess it. This could be due to the target system not having a customer entry that the source system did, and now it does, so we can load it. ODI handles this for us automatically through no additional effort on our part. So always try to design a job with interfaces if possible. Sometimes, however, actions need to be performed that don't quite fit into an interface. In these cases, we have procedures. For example, we could call a stored procedure in our database. The big win here for our client is that in instances where there's an existing piece of tried and true functionality in one of the systems that we want to leverage in our ODI job, we call it with a procedure. This reduces our development time and cost, as well as reducing risk. As an extra win, we've added documentation as to why we're calling the procedure, which we previously didn't have. So in ODI, packages are a graphical way for us to chain together multiple interfaces, procedures, and other steps. This is also where we can specify what to do in case of an error in a step. We can configure steps to automatically re-execute in case of an error. We can add a step such as send an email in case of an error. We use this extensively at our client to send an email in case something fails so the proper people know there is something they should look into. Simple as it is, this has been a killer feature for our client and has significantly increased confidence in their ETL solutions and data integrity. So after we've designed an interface or a package how we want and need it, we create a scenario from it. This is kind of like freezing a copy of the package or interface in place so that future changes to the package won't affect current executions. This way we can develop and enhance interfaces and packages without fear of breaking something. When our future changes are ready, we can simply generate a new scenario, schedule that one in place of or in addition to the current one. Scenarios are also the unit of work that we can call from the command line, such as if we want to use ODI routines in a batch file or existing business process. They're also the unit of work that we schedule to run in the ODI scheduler. The ODI operator is an interface for viewing all executed and executing jobs. It tells us what has completed, how long it took, how many rows of data it processed, if there were warnings, and if there was an error. We can restart jobs from here if need be. We can even resume them without having to restart them from the beginning. This can be incredibly useful if there's a long step involved that worked fine and it's just a subsequent processing step we need to attempt to rerun. This can save a ton of time. For our client, the operator's ability to look at the exact code a job step tried to run and the error message from that step, if any, has been a huge win. It has reduced the need to put all sorts of manual logging statements into processes, helps pinpoint issues very quickly, and the insight into the number of rows processed and job duration has been hugely insightful. The ODI scheduler gives us the ability to run jobs with very flexible scheduling options. We can run them daily, hourly, weekly, on the last day of the month, and all sorts of other combinations. I find it more useful than the Windows Task Scheduler or cron jobs on Linux. If you're used to setting up a Windows task to run a batch file to do automation, and all you're going to do is call an ODI scenario you've created, then definitely use the scheduler and save yourself some work. For our client, the ability to view the schedule on a grid has been useful, and the fact that there is no housekeeping step between creating the job and getting it into production has also been very beneficial. We just create the scenario, schedule it, and it's good to go. So we've talked a little bit about this already. Journalizing data sources gives us the ability to just process new and updated rows. For our client, this has been huge because they were processing blocks of data by day. For instance, a data movement process would say, let's take the current day, subtract 1 from it, and then process everything in that date range. This can work, but has several shortcomings. We can have timing variables to maintain. The data to process is a day old. What if something goes wrong and we need to reprocess data, and so on. Now we're just journalizing that data source, clicking on a checkbox in our interface to say, hey, ODI, only process the new and updated data, and we're good to go. As an added bonus, we can now process data several times a day, which reduces the load on the system, and we can have more timely data. We could have implemented this strategy in existing SQL code and procedures, but it would have been a lot of work. The JKM takes care of all the hard stuff, the boilerplate code for us, and that lets us focus on the what, not the how. Topologies are how we have saved a significant amount of effort at our client by not having to duplicate code for different environments. Going back to our customer example, we have a logical notion of what the customer data source looks like, and this exists irrespective of what server it's actually on, such as the production customer system or the development customer system. The interfaces that we design will only care about the logical makeup of the data. We'll create a development topology and a production topology. This will basically say that if a job is running in the test environment, then use this server. And if it's running in the production environment, use that server. ODI will connect to the proper servers, and now we're able to run the same job without having to maintain copies in multiple environments. This saves time, effort, and speeds up development. There have been many lessons we've learned at this client. First of all, It's critical to leverage someone who has done this before and can lay out the ODI foundation. It's extremely advantageous to set things up in the beginning to be ODI-esque with a good naming convention, topology mapping, and so on. It'll save a ton of time in the long run and lead to higher quality solutions. Start with a simple ETL job and build up to larger ones. This will help you map out your architecture, models, topologies, and so on, and let you know about any trouble spots or other issues. It can be very daunting to come out of the gate and try to go with a big bang approach. Don't lose faith on that first job. You might be very comfortable with your existing ad hoc solutions, and getting everything set up in ODI that first time can be a fair bit of work, but it pays off with higher quality and more robust solutions. Also, subsequent jobs get to leverage a lot of the same pieces, so they become much easier to create. Don't just recreate existing jobs in ODI with the same mechanics. Build idiomatic ODI jobs. That is, translate existing functionality into ODI concepts. If you feel like you're fighting the tool, then reevaluate what you're trying to accomplish. ODI solutions should feel natural. A seasoned ODI resource can really help with this. This applies to a lot of different kinds of development, but absolutely try to develop iteratively, such as develop an interface that moves data from point to point, but perhaps omit the data transformations. Try to become aware of performance issues as soon as possible in the process so you don't have to redevelop anything. Reuse topologies, models, variables, and anything else you can. Adopt a consistent naming system and documentation principles. This will dramatically improve long-term development efforts, solution quality, and maintainability. Again, hang in there for that first job or two and fight the urge to just do it the old way. You love the benefits that ODI brings to the table, and the doors will open in your organization. So ODI is Oracle's data movement tool standard. Give some serious thought about how to implement the platform. Advice and help from experienced experts will go a long way toward building a robust foundation that will improve efficiency and quality over the long term. Start with something small and work up to more complex interfaces and packages. So we're now going to shift over to the question and answer section of our webinar. I'll let Nissa kick it off.
To ask questions, go to the viewing desktop at the top of your screen and select Chat to ask Jason a question. In the meantime, while everyone takes a moment to enter their questions, Jason, I have a question for you. Several of my clients have asked me, what is the typical timeline to expect when implementing an ODI job?
So how long does it take to implement an ODI job? I'm going to go with the classic answer of it depends. It depends on how complex the job is, how much we have to set up for the job, issues we run into, and so on. So, for example, if the job works with a data source we haven't worked with before, then we need to map in the servers, import the models, and so on. So we want to use Journalized Data. We need to get that set up as well. So our time is going to be spent joining the source models together, defining the mappings, and validating the data. But the data validation step can really be the X factor here. On one end of the spectrum, you might have a simple job that takes less than an hour to knock out, but on the other, we could spend days or more creating the mappings process, loading test data, validating test data, tuning performance, and so on. So the better we are about setting up those models and topologies effectively to be able to reuse things, the more time we save in creating subsequent jobs. So, and a lot of the stuff we get for free, like job logging and info from the ODI operator. So I say overall, ODI jobs don't inherently take longer to develop than writing custom code, particularly when you take into account the other activities involved in the development process.
Okay, we have several questions coming in. Jason, how does job performance compare to writing native SQL procedures?
Well, let's keep in mind that ODI works with dozens of data sources, not just SQL or Oracle databases. So I'll kind of interpret this question in terms of performance compared to the original SQL de facto ETL solution for the client. In this context, the performance is the same or even better. That's because under the hood, the knowledge modules are actually writing SQL code for us. So the data movement is being facilitated in conceptually the same way as before. And ODI is not the middleman server that becomes a bottleneck and slows things down. So the reason it can actually be better is because the knowledge modules are expertly designed and tuned to craft queries in highly optimized ways that could actually be better than how we're already writing them. I mean, the guys that are working on this stuff should be working at NASA. They probably do.
Okay, here is another question. Jason, what all data sources does ODI work with?
Like I mentioned earlier, ODI works with Oracle relational databases, SQL Server, Hyperion Essbase, planning, Hyperion Financial Management, plain text files, XML files. I can consume data from web services. There's even some really cool new stuff they've just put in. It has connectors for what's called Hive, which is a cutting-edge big data technology that works especially well with the cloud. And connectors exist for tons of other relational database technologies. It's very likely that ODI works with the system you're using.
Okay, well, we are running out of time. I want to thank you, Jason, and I want everyone to know that we will get your questions answered, so we'll be contacting you. We want to thank you all for joining us today for the webinar, Oracle Data Integrator, a Success Story. And if you have any questions, please don't hesitate to contact us. Jason and Greg Alma's contact information is displayed on your screen. And thank you all for joining us, and y'all have a great day.